In problem number 23, it begins as x to the fifth y squared over x to the eighth y cubed. There are larger quantities of both x and y in the denominator. So I'm going to split the denominator this time. So leave the numerator as x to the fifth y squared. I'm going to write x to the eighth as x to the fifth times x cubed. And I'm going to write y cubed as y squared times y. So we've still accounted for all 8 x's being multiplied together in the denominator, and we've still accounted for all 3 y's being multiplied together in the denominator. We've just made it so that we can see division by 1. X to the fifth divided by x to the fifth is 1, and y squared divided by y squared is 1. So we're left with 1 over x cubed y. In problem number 24, it begins as 2x to the 12th times 5x cubed all squared times y squared. I'm going to clean up the parentheses first. We have to square both the 5 and the x cubed. 5 squared is 25. X cubed squared is x to the sixth. And we've got a y squared trailing off the back end there. Now we're just going to condense what we can here in terms of multiplication. We can multiply together the 2 and the 25 to get us 50. Like I said, 50. X to the 12th times x to the 6th is x to the 18th. And the y squared has nothing else to combine with, so we're left with 50 x to the 18th y squared. In problem number 25, the problem begins as 4xy squared plus 8x squared plus 3x squared plus 3y to the 7th. We're looking for like terms here. Well, there are no other xy squareds. We've got 8x squared and 3x squared. That gets us a total of 11x squared. And there are no other y to the sevenths. So that is actually the simplified expression for problem number 25 at that point. We were able to consolidate the x squareds. Problem number 26 is x to the fifth y over 4 times 4x to the sixth y to the fourth over 2x to the fifth y. I'm going to multiply those two fractions together first. So 4 is the only thing we have left in the numerator for a constant. X to the fifth times x to the sixth is x to the 11th. And y times y to the fourth is y to the fifth. In the denominator, we can multiply the 4 and the 2 to get 8, and x to the fifth y. Now I'm going to split that into 3 fractions here, just for the time being. So we're going to have 4/8 times x to the 11th over x to the fifth times y to the fifth over y. And we're going to simplify each of those fractions individually. 4/8 is 1/2. X to the 11th over x to the fifth, we can rewrite the x to the 11th as x to the fifth times x to the sixth, still accounting for all 11 x's being multiplied. Then the x to the fifths will divide out to 1, and we're left with x to the sixth over 1. In the y to the fifth in the numerator, we're going to write that as y times y to the fourth, so we're still accounting for all 5 y's. The y to the first will divide out, and we'll be left with y to the fourth over 1. Condense that all back together, and we get x to the sixth, y to the fourth over 2.